on this problem. I'm setting up a chart that has a bunch of possible measurements for two pulleys, A and B. And we're saying if we have a diagram that looks like this, A and B, and we're given the diameters of each of these pulleys, we're trying to figure out what the pulley ratio would end up being. And you can see the pulley ratio on each of these is going to be A over B. So we'll just go ahead and write these as ratios. So first off, if we know the diameter of A is 8, the diameter of B is 6, then we know A and B essentially. So A over B is going to be 8 over 6, which I could reduce down to 4 over 3. It looks like these two are ratios of something over 12. I'm not sure exactly why that is, but we could convert this to a ratio of something over 12. Instead of dividing both the top and the bottom by 2, I could multiply both the top and the bottom by 2, giving me 16 over 12. It depends what's being asked for in the question. If they say make the second number in the ratio equal to 12, we'd want to give 16 over 12. Otherwise, we'd want to do something, just reduce it down to lowest terms. All right, so how about if we have something like this? We have the diameter of the first pulley, we don't have the diameter of the second, and we have the pulley ratio. So we know that 7 over the unknown diameter, this B, I'll call it B for the moment, is equal to 3 over 12. So how would we go about solving something like this? Well, it looks like this is just a proportion. We get that 3b equals 7 times 12. When we divide this 7 times 12 divided by 3, I'm just kind of putting it all together so I can plug it into the calculator all at once. We get 7 times 12 divided by 3, which gives us 28. So that means this value here would need to be 28. And I kind of neglected, I didn't write any of the units on here, but if there's no units written in a ratio, it means you can essentially use whatever units you like. And we were told that this is a number of feet, which means this one would have to be a number of feet so that they would match. So we'd have 7 feet divided by 28 feet in order for that to be the same, in order for those to be able to cancel out. All right, let's do this example here. If we say the ratio, or the diameter of pulley A is unknown and the diameter of pulley B is 20, we want a ratio of 2.4 to 12, I would say A to 20 is equal to 2.4 to 12. And again, it's a similar sort of thing. Instead of setting up the full ratio or the proportion, I'm just going to multiply both sides by 20, because this gives me one way to solve that equation in one step. A is equal to 2.4 times 20 over 12, and then I can plug that into the calculator. You might notice that eventually, if I was to do the cross multiplication and then divide both sides by 12, I would get here also. But another way of looking at this is saying what number divided by 20 equals this number. Well, if I just multiply that number by 20, I just get back to the original number. I say what number divided by 20 multiplied by 20. Well, we just get back to A. So I do the same thing over here, and we get this. 2.4 times 20 divided by 12 gives me 4. Now, I should point out that I'm not having to be very careful with my order of operations here. I know that how I've written this into the calculator, this multiplication is going to take place before that division, because they're tied in the order of operations, and the multiplication is on the left. So that's how I know that this multiplication is going to take place before that division. And that's actually how I have it written here. I have this multiplication before that division. And there's a couple of different ways you could write that in your calculator.